Hello everybody, I want to have a discussion about infrared laser technologies. In fact, I would like to explore CO2 and chemical lasers. Infrared plasma lasers are mainly including CO2 and chemical lasers. They are able to emit the powerful long wavelength IR radiation. They are used in industry, medicine, defense, which is due to their high energy, precision, and range. In this talk, I will cover CO2. I will talk about the CO2 plasma lasers and I will continue with chemical infrared lasers. The key focus in my discussion is on their principles, mechanisms, applications, innovations, and finally, I will provide you a comparative insight for this between these two different lasers. I will start with principles and mechanisms of CO2 lasers. Their output wavelength is 10.6 micrometers, which is in the IR range. The gas mixture is comprised of CO2 plus nitrogen and helium, and their plasma excitation in these lasers is based on electrical discharge or RF methods. Energy transfer in these lasers is based on electronic excitation of nitrogen. Then it's nitrogen. When nitrogen absorbs this electronic excitation energy, it will transfer it via a vibrational excitation to CO2 molecules, and finally CO2 emits IR via the stimulated emission. The role of helium here is very much important. Helium will be very much helpful to remove the heat and also collisional de-excitation. About their design and operation, their components are mainly including gas-filled laser cavity electrodes for plasma generation, optical resonators, which is comprised of one full mirror and one partial output mirror. As I have already told you, the process is based on electronic excitation of nitrogen, which is followed by vibrational energy transition to the CO2 and finally lasing. The resonator function is based on light amplification and beam extraction. Their application and advancement, their applications are mainly including in the industrial, as I have already told you. These lasers are being used for cutting, welding, and engraving. And in the field of medicine, they are used for surgery, dermatology, and resurfacing. And for such many years, these lasers are being used in different applications in the field of defense, for example, LIDAR and directed energy systems. But still, innovation R&D activities are being done on these lasers. For example, RF excitation, micro channel cooling, adaptive optics, wavelength tuning. Especially adaptive optics is very much important, and many people are working on that around the world. I would like to continue my discussion on these infrared lasers, on chemical infrared lasers. Their mechanisms is based on exothermic chemical reactions which excite HF or DF molecules. The lasing medium, when we use HF, emit the wavelength of 2.7 micrometer, and when we use DF, it emits 3.8 micrometer as the output wavelength. The system is including flow reactor plus optical cavity with mirror. Their K strength is mainly related to the fact that they have an extremely high power output, and also they are able to produce the modes in the they are able to produce different modes, continuous and pulse modes. Their applications, I have already told you, are related to the military and industry. In the field of the military, these lasers are being used for missile defense and high energy weapons. And in the field of industry, they are used for material processing with high power needs. But the main challenge with the chemical lasers is related to this fact that when we are working with these lasers, we need to handle reactive chemicals, which are known as environmental byproducts, and they are very much important. And many people are working to remove these issues. Their developments, as I have told you, is based on many works are being done on these lasers, but their development also by many researchers and scientists around the world is being done, and they are mainly working on on the safer reactions, closed loop systems, alternative materials, modeling, and miniaturization. Here I have provided you a table to compare these two different kinds of lasers. About the output power, CO2 lasers have a high output power, but chemical lasers have an extremely high output power. Their medium in the CO2 lasers have a plasma gaseous mixture laser medium, but the chemical lasers are having the reactive chemical, and we work with reactive chemicals. The output wavelength for the CO2 laser is 10.6 micrometer, but for the chemical lasers, when we work with HF hydrogen fluoride, we can have 2.7 micrometer as the output wavelength, and if we work with DF, we can have the zero point 0.8 micrometer as the output wavelength. About the applications of CO2 lasers, I have told you they have many applications in the industry and medicine, but the chemical lasers have many other applications in the field of defense, and interestingly, we can develop the chemical lasers in the large scales. CO2 lasers are still having the challenge with thermal control, but the chemical lasers, as I have told you, have a big challenge with the safety and environmental issues, since we are working with the chemical products, and the byproducts will have environmental issues. Um, Still, works are being done on these two types of lasers. For example, for CO2 lasers, people are still working on the plasma physics, chemical dynamics, and for both lasers, people are working on the system efficiency. However, the next generation of these lasers should be compact, and we need to integrate these lasers with AI monitoring systems. And also, the most important issue is related to have a sustainable operation for both type of lasers. However, it is predicted if we can remove these issues with these two kinds of lasers, they can be used for precision agriculture, space sensing, and biomedicine. However, finally, I would like to tell you that IR plasma lasers are central to the high-power, long-range precision tools in the science and industry. I hope you have enjoyed with this talk about these high-power lasers. Thank you.